Thanks for coming. My name is Richard Turner. I work as a program manager on the Indigo team. We've recently actually had a reorg inside Microsoft, shuffling groups inside the right places that they really should live. And our group is quite an interesting one because we own both the very old as well as the very new. So we own everything from DCOM, RPC, COM+, Enterprise Services, Remoting, ASMX, and also we own WSE and, moving forward, Indigo. Okay, so we're building and managing all of this stuff. So we essentially own the distributed application stuff for Microsoft. Okay, so if anybody hasn't found us yet and you have interesting questions or problems that you'd like some assistance with, we have a couple of stands over here in the Cabana session, stands 5 and 6. So just on the left-hand side as you come out of this room. So come on over and have a chat, meet some of the actual devs and testers and program managers that actually build this stuff, and let us know what you think of our bits and how you think they should work, or whether you like them or not. Give us the feedback. It's very important you do so right now, actually, because we're right in the middle of a coding cycle on Indigo in particular, and we want to make this a truly compelling platform for you to write distributed applications on. But we're not going to be speaking about Indigo today. Can I just ask, just as an idea, how many of you use native technologies today? So VB6, C++ as your primary development tool. Okay, that's dropped a heck of a lot since last year. That's good to see. Of those of you that are left, I'm guessing the rest are working with managed technologies. So who's using enterprise services? Okay. Who's using remoting? Okay. Who's using MSMQ? Right, good. So we're going to be... Oh, and who is doing web services? ASMX web services. Good grief. Wow. Of those of you building web services, how many are publishing their web services to the outside world? Very few. Okay. That's consistent with our experiences. And in our experiences... You'll probably know yourselves that we're seeing web services being used to really glue systems together right now. That's primarily the reason that people are using these things, especially in the enterprise data centers. Now, what we're going to be discussing in this session is how to make best use of our existing technologies. Who likes coding enterprise services? What, just two of you? Come on. Who likes coding remoting? Okay. Who likes coding ASMX? Find it productive? Right, cool. Who likes coding MSMQ? Or System.messaging? Does anybody like having to code different ways for each of these different technologies? Good, not one hand. That's what I was hoping for. Okay. When we come towards Indigo later on, we will be having one code stack. But right now, what do I do to build technologies today? And how should I think about building those technologies? Who was at the Don Box talk just now? Okay, who wasn't? Okay, a fair few of you, good. So Don and Doug on stage gave you an interesting idea as to, or an interesting approach to thinking about future development strategies and technologies from Microsoft. There being one program that we're all trying to complete. I'm going to take a slightly different perspective and illustrate and introduce you to some of the key elements of service orientation, why it's so important to us, why we believe it's absolutely fundamental to get service orientation into people's heads and to get people discussing it at least. We're not saying you have to buy it wholesale, but we believe it has significant value to use enterprise developers or distributed application developers or home application developers writing networking technologies even. Okay? So... here we are. Hopefully you've turned up for the right session. We have a number of sessions in our track. We have a connected systems track. And what we tried to do for this track was to give you a really good broad base of content, material, and discussion around how to build distributed connected applications. Okay? We didn't span as far into device space as maybe we would have enjoyed having the time to spend playing with the devices, except for those of us with far too much time on our hands, not. But we'll be seeing how we actually go ahead and build enterprise class and distributed class applications through these various tracks. So if you're interested in this stuff, take a look at what else is coming up. There's quite a lot of interesting stuff coming. So what we'll be discussing in this section is what is service orientation. Has anybody actually been looking into this? Does anyone think they understand what service orientation is? Yeah? I'd be willing to put money on the fact that no two of you in this room would agree on what it is right now. Unless you just regurgitate Don stuff that you've just heard. If you go and do a search on Google for service orientation, you'll end up with 30,000 hits with various people spouting about what they believe SOA, in particular, service-oriented architecture, or is their application. What SOA is to them, to their particular mindset. And what we've come to find is that there's no concrete definition, no really concise, really tangible, concrete definition of what service orientation is, and we will be discussing that for the first few slides as we go through. And then, okay, so if I buy this SOA idea, or this service-oriented idea, then how do I go ahead and start building these applications today? What are the recommendations? Which technology should I use in which scenarios? And which technologies not to use in certain scenarios? Okay? And then we'll have a brief section on the end in terms of performance. We've got a few bits to mention in there as well. So, what is service orientation? There is a link at the bottom of this screen. It's almost falling off, but not quite. It's from the MSDN article that we published, or sorry, the Don Box published, just as we went to PDC last fall. Anybody at PDC? Okay, there's a few of you with good expense budgets then. So, at PDC we announced Indigo, and that was really where we first came out and we first talked about service orientation in any reasonable sense. Pat Helland has been talking about stuff that has affected our service-oriented vision for some time, but we didn't really start getting concrete about it until we came to PDC. Now, the concept with service orientation, how many of you were in the industry late 80s or beginning to enter the industry late 80s when we were moving from procedural programming to object-oriented programming? There's quite a few of you. Yeah, cool. Excellent. So, if you remember back then, the huge mind shift that you had to go through to go from, I now have a linear list of functions that my program consists of, and I have to glue those things together, and there was very little structure, to, I have a class, it has methods, it has properties, it has attributes, it's tangible, it becomes more real to me. Now, when we move to service orientation, we expect a similar kind of mind shift to be required, because it does require a bit of a leap of faith in order to adopt this new mindset. And the benefits of this mindset are many, and we'll be discussing some of those shortly. Okay? Service orientation is not about a particular technology. When you hear, for example, Doug and Don earlier talking about service orientation and immediately mentioning things like WS*, the WS* protocols, or SOAP, or HTTP, or any other vendor mentioning any technology in association with SOAP, then that's a good thing, because it means that people are trying to map this stuff to their features, to the technologies that mean something to them. But service orientation as a mindset doesn't have any relevance to any particular technology until you choose to map it. Okay? So service orientation is an approach to building systems using services which adhere to the 4 tenets of service orientation. Okay? Now, if you go and do a search on MSDN on the 4 tenets of service orientation, you won't find anything yet. We are in the process of writing a white paper, and Matt Powell down the front here, who owns the Web Services Dev Center on MSDN, will hopefully be publishing this in all its newfound glory when we eventually get the damn thing finished. We've been a bit busy trying to get TechEd going to actually finish this off. But these 4 tenets are absolutely key and crucial. And we bear these tenets in mind every single design review we go through with Indigo, and most of our other technologies now. We're working across the organization to make sure that we as a company best represent these principles. And we'll be stepping through these principles shortly. Okay? Tenet number 1 is boundaries are explicit. That I enforce the only way that you are going to speak to me is via a technology exposed at my boundary. I haven't defined the technology at this point. I assume that services are autonomous. One of the problems that we've had, I've worked in various organizations, and one of the principles that we always used to start with was start with a database and work upwards. So we start with a third normal form out of our ears, and then denormalize it to a point where we could actually work and deploy with this thing. And then we'll build a bunch of componentry on top of that, and we'd have this layered architecture, and then we'd have user interface on the top end. And that was great. That was great. We got systems developed and delivered that way. And then something needed to change. typically quite low down. And then we had to refactor components in the middle of this system when these components were stuck together very, very tightly. And it's very, very hard to remove a single brick from a wall and replace it with a brick without pulling the wall down. Okay? This is why systems tend to be quite fragile today. There are a lot of interdependencies. There's a lot of hard coupling. I've built systems before where I have a database in one area of my business, and I want some information from that database to be exposed through, for example, a web UI. And what I might do is actually replicate that data into the data store closer to the web UI so that I can expose it to the outside world. That's all very well and good, but as soon as they change the data model here, it hits me, and it hits the 50 other people that also touch that database. There's close coupling there as well. Okay? Now, if we assume that a service is an entity which is completely self-contained and is completely able to run and operate itself with or without its partners, then we have the ability to pull and replace one of these services as we go along much more easily than we ever were able to in the past, just as long as we speak the same language on the wire. And what about that language on the wire? How do we talk? How do we express what our service looks like and what kind of information I'm going to expect back from the service if I make a call, and what kind of information do I have to pass my service in order for it to get its job done? That's what we talk about when we say share schema and contract, not class or not objects. Okay? It's very important to understand that when we move to the web services world, when I make a method call against a web service, I'm passing it data. I'm passing it data values, essentially, in order to get something done. Even if I pass it something I call a purchase order, I'm actually streaming my purchase order into typically XML and streaming that across the wire. I'm not passing a reference to the object running inside my service. Okay? If I do that, I'm tightly coupling these systems together. The destination system has to understand what this numeric address pointer actually means and how to affect that inside my system. If I do that, I'm automatically tightly coupling things together. And we're saying, if you avoid doing that and pass data by value instead of by reference, essentially, then we end up being able to decouple things far more aggressively. And probably one of the most powerful things in terms of the service-oriented mindset is the concept of policy. I have no ability right now, until WSE 2 came along at least, I have no ability right now in reality to express what you need to do in order to speak to me, the service. I can say, here's what I look like, here are the types that I accept, here are the types I'll pass back to you, some basic information about type and schema, but I don't tell you, you need to support WS security in order to speak to me. The only place this information tends to be held is either, if you're very lucky, in an operations manual, or very unlucky, in the operator's head, in your ops manager's heads, in your deployment guys' heads. Because if they move to another company or, God forbid, get dropped under a bus or something, then all that information is gone. We need the ability to express what higher order semantics around our services, how you will speak to me, over what protocols. What security semantics do you need to support in order to communicate with me? Will you support some form of binary serialization, or will you support XML HTTP? All of those kinds of questions are built into the policy concept. Okay? And again, we've not mentioned technology once. So, just for clarity, we're going to define a few points, because we want to be very, very concrete. We want to be very, very accurate about how we define the concept of a service and the concept of a system. So we're saying that a service is an entity that you interact with by passing messages back and forth to it. Okay? Service-oriented systems tend to be message-oriented. They tend to involve passing messages back and forth. Cool. Services are built to last. They're built to assume that things are going to change. They're built to do whatever they can to make themselves as reliable and as resilient and as secure as physically possible, regardless of what the outside world does. So my service might involve a bank of web servers at the front end, a bank of middleware if necessary, and, for example, a clustered database environment if necessary, in order to ensure that I am able to meet my SLAs as a service. Okay? It's an important concept. Typically, we tend to think of systems and say, well, this entire system has to have an SLA. Great, that's all well and good, but you're only as strong as your weakest link. And so if each service vendor offers to or accepts that he has to make his or her system as reliable and as secure and as available as possible, then the whole system will benefit from this. A system is a set of deployed services all cooperating on a given task. And that term cooperation is incredibly important. This is cooperation. This isn't hard-bound linkage tying two systems together until the end of time. Okay? This is opting to cooperate. This is discussion via policy to determine how we will communicate with each other. To give you an example of policy, sorry, I'll give you an example of policy shortly. And we assume that services are fractals. Inside a service might be more services. And inside those services might be more services. And so on, and so on, and so on. Now, many of you may have questions. How big does my service need to be? How small does it need to be? Where do I define my service boundaries? And to be honest, you're going to be able to take as good a guess as that as we can. It's all about common sense. It's about understanding the geography, the political landscape, the security limitations you might have. If you have to put a firewall in between two things, then typically that's a good service boundary line. If you're crossing organizational boundaries, again, that's a pretty good service line. But you can then group multiple services inside a bigger service and inside a super service again. Your bank might expose the features that you can access via web services as a service to the outside world. That's not implemented in one service, probably implemented in several hundred services internally. Okay? So think of services as fractals. Start with something that you can understand initially and start delving inside that. Okay, so I've got one of these, so I'm going to comprise it of this, that, and the other. This thing I can now decompose further still. In a similar way that we used to think about designing objects and designing classes in object-oriented world. Okay? So the concept, sorry, too fast. Animating slides, my goodness. So, our bet is that there will be services everywhere. Microsoft is absolutely betting the farm on this service-oriented idea. Indigo is probably the most fundamental rethink we've had in terms of a core technology in quite some time. And it is absolutely fundamental to the entire Windows infrastructure. And we believe that building services will inordinately improve the way that you design, implement, deploy, manage, architect solutions in your environment. So here's an example of a service decomposing into further still services. And we could take, for example, that New York operations service and break that down. And we could take whatever's inside there and break that down. Okay? So this level of thinking is not too different from where we were. Now, the important thing to understand as well with service orientation is it's not saying that object-oriented technologies are bad. Objects are great. Objects are how we are able to make sense of very complex things much more easily than we ever were before. But objects don't necessarily apply well to a decoupled, far more dynamic, far more changeable world than we've been used to in the past. Let's just think about the nature of change for a second. How many of you 4 years ago would have thought that IBM, BEA, Microsoft, Oracle, Sun, and others would all be agreeing on a wire standard protocol that they would all be communicating with? 4 years. 4 years ago, we'd only just launched ASMX. 4 years ago, we were arguing about whether Java was better, or C++ was better, or C# was better, or Perl, or Python, or J2EE, or we were having all of these arguments, and when it came down to it, the interesting thing is that we have incredible capability in our systems today. We have very, very sophisticated purchasing systems. We have hugely powerful ERP systems. We have great manufacturing systems. And right now, we have a heck of a time trying to stick these things together to build something the business wants to see, where for example, Microsoft now finally, it's only rolled out about 2 months ago, but I can now automatically deposit money from my paycheck into my meal card so I can go to the canteen and buy stuff. Before that, I had to go to the ATM, take money out, then go to the cash out and give them money. This is Microsoft. We build our own internal systems. Yeah? Hooking stuff together has traditionally been incredibly hard. But now with things like web services and a service-oriented mindset, we can start thinking far more liberally about these things and actually getting completely disparate systems to talk together for the first time. And this isn't just about desktops and servers. This goes much wider and much broader. So why is service orientation important? Hopefully you started to get an inkling as to why we think it's important. But it does provide us an opportunity to rethink how we go about designing and building tomorrow's systems. If we carried on today with our existing object-oriented mindset, we'd be building further and further more fragile systems, more and more tightly coupled systems, and we would never break this rut that we seem to have got ourselves into as an industry, as a whole, in terms of being able to actually say, I have two systems. I don't know what's in them, I don't care, but I can understand what data to pass back and forth between the two of them in order to get them to speak. Okay? Minimizing hard interdependencies and enhancing independence is going to provide us an enormous amount of flexibility moving forward. It enables an extraordinary level of interoperability. And it makes explicit some of the core assumptions that compromise today's systems. When we today go ahead and design, for example, ComPlus or enterprise systems components, we think about them in our local developer sense. And we sit on our machines and we write these components and we build them, we test them locally, it all works fine. And then they get deployed into the live environment, where they might be residing on a machine remote from the client application against which they were designed, and we wonder why the performance doesn't necessarily meet our expectations all the time. I was going to say something else, but I bit my tongue. Okay. So our expectations around systems need to change. We need to make broader assumptions around, I have a service. I am here in my client. Where is the service? I don't know. But I don't need to make hard decisions inside my code that determines a particular wire protocol I might be using, or that determines a particular type of wire formatting that I might use. That's infrastructure stuff. My code does this. It wants to use this service in this way. That's what we should be talking about. And that's what service orientation gives us. Okay. So in terms of different mindsets, different consumer mindsets, it gives us a number of benefits. I think we can see some of those benefits from the discussion we've just had. So in terms of practicalities, notice we've not mentioned a technology really yet. I mentioned a few in passing. But service orientation is about a mindset. It's about a paradigm. It's about a way of thinking about a problem. Okay? So how do we now start to make this real? We need a common language for expressing schema and contract and policy. We need a common language to express what is our boundary and how you shall interact with us at our boundary. Okay? When we think about the granularity of a service environment extends only as far as we agree on the expression of the boundary. If I say, my accounting system is now a service, I'm going to expose it using a service technology to the outside world. Great. That is the extent of my boundary. And I will then iterate in on that because I have control of everything within it. If I try and force others that use my service to use some arbitrary expression or technology that I've implemented, the chances are that's not going to work. I was doing some work with some UK banks. Sorry about the accent, I haven't learned American yet. But I was doing some work with some UK banks several years ago when they all started getting onto this web thing. And each individual one of these banks wanted to implement their own communication protocol, their own communication mechanism, their own backdoor, trapdoor. It was an absolute nightmare trying to work with any of these things. Okay? Affect what you can. Make your stuff as easy and as secure and as reliable as possible to use, using the standards that everybody else is adopting as well, and the chances are that you'll be swept up with a wave. Okay? And build service-oriented systems that want broadest possible interoperability against the WS star family of protocols. You could, there's no reason at all why you couldn't go ahead and design a service-oriented application using completely different wire formats, completely different semantics, completely different protocols if you wanted to. But you've got to convince enough people that it's a good thing for them to go and spend the time tooling up to do as well. the chances are it's going to be very difficult for you to do that. It's much easier to leverage the shared work that's been used, so that's been put together by IBM, Microsoft, Oracle, Sun, and hundreds and hundreds and hundreds of other vendors, HP and everybody else involved. Okay? Take this WS* suite of protocols and believe it's going to work, because it's the best chance we've got, quite honestly, of making this stuff happen. And you can do it now. Starting this week, we've launched WSE 2 this week now, finally. And was anybody on the beta program for WSE 2? A few of you, good, okay. So start looking at WSE. If you need WSE to give you a hand with adopting the WS protocols, if you need, for example, to exchange information with business trading partners, how are you going to secure that link? Is SSL good enough for you? Or are you going to put WS security in place? It's your choice. But if you need to go down the WS* route, then WSE is a very good place to go. We'll be mentioning it shortly. So what else can I use to build service-oriented technologies? And more accurately, in the Windows stable of technology, we have quite a broad range of capabilities and sophistication across a broad range of technologies now. And what we wanted to give you is to give you some rules of thumb. These are not rules, as in break them and you are bad. These are rules of thumb, guidance, guidelines. There will be exceptions to these rules, but by and large, this is where we strongly, strongly urge you to consider moving. Okay? And to consider focusing your efforts, and to consider not departing from this path unless you really have to, and there are, we know, caveats that will mean you have to do that. So design with service orientation in mind. Start today. It really does make a dramatic difference to the way in which you architect and design systems when you start thinking of things as services. And you start assuming that the only way to interact with this given service is via some known message format. Okay? And that message format is open and standard. It can be tricky to do service orientation today. Policy in particular is the fourth tenet, if you remember. And policy is a little bit tricky to implement right now, but WSE will give you a chance at doing that, at least in the first iteration, if you need to do policy-type negotiations with others. Okay? Indigo will make this a heck of a lot easier as we move forward. So, adopt open standards at service boundaries. I think you can start to see a pattern emerge, hopefully. Use HTTP and TCP as your transport protocols. Use XML as your payload. Use SOAP and WS security and WS addressing and WS policy where necessary to implement the things that you need to do. Oops, sorry. Clicker's not. Okay, there we go. So, in order to do this, which technology should we use? Now, you might have heard Don speak earlier and say, as a general rule, we strongly recommend that if you have a question such as, which technology should I use to implement X, start by assuming ASMX. This may sound contrary to your preconceived ideas as to what ASMX may or may not be. Is it performant enough? Is it secure enough? Is it resilient enough? We strongly suggest you use ASMX for a wide variety of reasons. And we're actually publishing a bunch of papers on why this is our recommendation shortly. Okay? This is being written up as we speak. If you need to do complex componentry, if you need to do complex transactions spanning multiple operations against multiple objects, then we suggest you carry on implementing that stuff in object technologies and component technologies, but keep that stuff inside your service boundary. If you need to coordinate between services, one of the things that you must assume is that any service that I previously depended upon may not be there from one minute to the next. It's an uncertain world when you move to service orientation, and it's an uncertain world anyway, quite honestly. The service orientation helps make that more explicit. Okay? So keep components inside your boundaries, but use component technologies inside those boundaries to carry out the traditional complex business logic type operations, but expose them to the outside world using ASMX, for example. Use System.messaging for async and queued messaging if you need to. But again, front your queues if you can, or if you are willing, with ASMX Web Services. The benefit of doing this is that ASMX is very closely aligned to the service tenets. Sorry, to the service-oriented tenets. It is an expressive boundary technology, allowing you to express schema and contract, and not classes. It forces you to not pass object references back and forth, and starts moving you very, very close to the kind of mindset and the kind of approaches you're going to need to take when moving to something like Indigo, for example. Okay? And it has great interop support. The vast majority of you who put your hands up here saying that we're using web services inside our organizations are using them inside your organizations to stick stuff together. Not to expose some fancy dot-com bubble type idea business to the outside world, but actually to start sticking things together. So ASMX is a great way to start doing that. If you need advanced web services, use WSE. It's a great technology. It's now had its support extended as well, so WSE will be supported as long as .NET Frameworks 1.1 will be. Okay? So it's not the limited support that WSE 1.0 is currently going under. All right? And it is our speedboat tracking technology that keeps you ahead of the game, or at least in line with the game, when it comes to adopting standards. But if you don't need to adopt those standards, if you're working entirely inside your organization, entirely within your trust boundary, and within your political boundary, you may not need it. So don't use it just for the sake of it. Okay? And this has great scale-out capabilities. Has anyone ever tried load balancing across a bunch of complex objects? Complex components. Okay. Anyone enjoy it? Anyone using CLB? 1. Okay. So if I'm implementing a system using enterprise services, and I say, okay, that's working fairly well in my 4-way box, and now I double my incoming workload, what do? Do I buy an 8-way box, or a 16-way box, or a 32-way box, or what? Because the only story really is scale up, apart from component load balancing, which comes in App Center. Okay? If you move to the web services world, however, and you consider that I now have a machine with ASMX fronting the outside world, and all my COM componentry probably on the same box, I can load balance the heck out of that thing as long as you've followed our prescriptive guidance in terms of making your application stateless. You get free load balancing, essentially. And while the individual call time may be slightly longer than you might have experienced with DCOM in the past, it means that you can handle far, far greater load overall. So there are benefits of doing so in terms of performance as well that you may not have thought about first of all. Remember, services are fractals. Consider ASMX inside your services. If you don't need transactions, if you don't need just-in-time activation and pooling and all of those object semantics that you've become used to with things like Complas and Enterprise Services, we suggest you consider just writing ASMX code. Your ASMX code is compiled and runs as machine code when it's run, so why not use it? Okay? But if you need the more involved, lots of objects, spanning transactions and things across them, then Enterprise Services is a very good technology to use. We're going to be doing an awful lot of work to make sure that your code migration path from Enterprise Services to Indigo is going to be a very smooth one. And we're also doing a heck of a lot of work to make sure that Indigo and Complas will interop nicely on the wire, so that we're not having to force you to go to Indigo in order to take advantage of some of its capabilities and services. So one of the things that you might have seen in Server 2003 is that you have the option of specifying expose my Complas application as a SOAP service. And what that actually does is underneath the hood is it builds up a remoting web service proxy essentially to your Complas object. Okay? Now when Indigo comes along, what we're hoping to be able to do is to provide a means very similarly where you can say this existing Complas component expose it as an Indigo service. Here are a few attributes and settings we might give you the option of setting. Go. And it builds an Indigo proxy for you underneath the hood. So that anything that's talking DCOM will still talk via normal means to your component. But anything else that you start building in Indigo can also start talking to that component. And Indigo thinks it's talking web services. The component thinks it's talking DCOM. And we're doing all the bits in the middle to confuse the hell out of everybody. Okay? And convince them they're actually talking to the right thing. So not only will we be giving you a great code migration path from enterprise services, we'll also be giving you a great interop story as well, integration story as well. You might have heard Don and Doug mention this as well on stage earlier on. Okay? So if you need to do asynchronous comms, actually, I was going to update this slide, but I decided to leave it as it is. MSMQ is a great technology to use for asynchronous stuff. Some of you may not know, but MSMQ, until fairly recently, was a technology delivered out of our Israeli office. And we actually shipped the entire team and the product to Redmond and bound them into our development and test and full product cycle because it's such an important technology for us, especially when we moved in towards the Indigo world. MSMQ is not going away, believe me. We were asked several times already this morning whether MSMQ has a shelf life, whether it's going to be deprecated and so on. MSMQ will be the queuing engine underneath Indigo when you decide to use Indigo's queued method invocation capabilities. Okay? MSMQ is the engine that will be providing the queuing transport, essentially. So investing in MSMQ is certainly not something you're going to regret. So one of the other great things about MSMQ is it gives you the opportunity to build very, very, very scalable applications. It's especially useful when bridging the impedance mismatch between, for example, a very high chat conversation with lots and lots of dynamic customers on the outside world and updating lots of very, very laborious batch process-oriented systems at the back end. They don't tend to mesh very well together. And what we recommend is you consider putting queues in the middle, where your client application just goes, put a message in that queue, I'm done. I'm back to my clients. Put a message in the queue, I'm done. Back to my client. And the back-end processing engine can then pull these messages off the queue as quickly as it can, at its own speed. If it goes down, the queue's message will still be there, and it will be able to pick that up. And it's a great pattern to be able to build really, really scalable systems. We built the UK government gateway actually using a combination of MSMQ and BizTalk, and simply used BizTalk as just a queue that was able to handle bigger messages. Okay. The System.messaging namespace itself as an API doesn't move forward into Indigo. The queuing technology and everything underneath it will do, and you'll still be able to use the System.messaging namespace from within your Indigo code if you want. We're just not applying the methods and the properties that you get inside System messaging to the Indigo APIs, essentially. Indigo will essentially provide a seamless way for you to be able to specify, my method accepts queued capabilities. My class here, it supports queued method invocation. And we do everything underneath the hood for you so that we dispatch messages via the queues. Okay? So MSMQ, not going away. Com+, not going away. We haven't mentioned remoting yet. Now, I noticed there are a lot of you in the audience who are using remoting at the moment. And we want to make very, very clear. Has anyone read my blog as a matter of interest? We went to PDC a little while ago and said, oh, yada, 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 Indigo. Oh, look how cool Indigo is. Indigo is so cool, isn't it? How great is that? By the way, we've got some prescriptive guidance around remoting, and our prescriptive guidance is to use remoting where it is absolutely appropriate. Remoting is a great technology. It's fabulous to play with, especially if you're a propeller head. Okay? It's great fun. There's not many technologies coming out these days that gets you that close to the wire, quite frankly. Okay? But use it inside your services. Use remoting for cross-app domain communications inside the same process. Because, quite frankly, it's the fastest way of doing so. Use remoting for handling custom wire protocols if you need to handle custom wire serialization. We did this in the UK for a bank, actually, where they had this text-based, almost tab-delimited wire format. And we wrote a remoting proxy that took the XML coming in and transformed it into their format on the outside, going on the outside world. And within the space of about 10 days, we'd managed to do something they'd spent months trying to do with other technologies and failed. It's great for getting really close to the wire, and it's great for going cross-app domain. Is it the fastest technology in the world for going from one service to another? No. DCOM is. DCOM's a 15-year-old technology that's had the guts tuned like nobody else on earth. This thing is really, really tight and fast. Is remoting able to approach that speed in certain scenarios? Yeah. But if you want the absolute speed benefit of, you want the absolute maximum in terms of performance, then we consider DCOM to be our fastest wire format, essentially. And the other benefit of moving to enterprise services and using, therefore, DCOM is that you can secure the wire, which you don't get with remoting. You have to write that stuff yourself. Oh, and it's got an object lifetime management engine as well, which remoting doesn't. You have to write that too. So as soon as you start getting into discussions around remoting, is it the best technology to use for my scenario? For your scenario, it might be. But we suggest that there are typically other alternatives that might render more benefits to you. Okay? Be aware that if you do write remoting components and you do implement custom channels and syncs, that you will be responsible for porting those custom channels and syncs to Indigo if you choose to go that way. We're going to do as much as we can to provide a simpler mechanical code migration process for you, but we can't do everything, and we certainly can't we can't suppose to understand what it is that you might be doing in your custom wire handler or your custom protocol handler, whatever it is. So you'll need to do that. So if you do need to do custom wire protocol handling, or you need to do some custom funky stuff in channels and syncs, be aware that you should abstract that stuff away from the processing logic of your application itself as best as possible. Okay. Also note that remoting does SOAP RPC encoding. And at the time that we implemented remoting, that was pretty much the way that most people were going. And since then, there's been a bit of a sea change towards different encoding mechanisms. So one of the other problems with remoting is if you go and build a large remoting infrastructure now, and you're expecting that to be able to operate, for example, with Indigo on the wire, then you're probably going to be very disappointed. Okay? Because Indigo, along with the rest of the web services industry, is going for doc literal. Okay? Going for a different encoding mechanism. So yet another reason to consider your options carefully when it comes to remoting. Does this mean that remoting is being removed from .NET? No. Does this mean removing it from the frameworks? No. Will it be there in Longhorn? Yes. Will it be there post Longhorn? Yes. Same applies to COM+, MSMQ, and all of our existing technologies. We're not removing remoting from the stack. We're just providing a better way to do what remoting did in Indigo. Okay? And until Indigo comes along, we suggest that you think judiciously about when and where to use remoting. Okay? So, today's caveats. If you are using ASMX, try and avoid using the HTTP context object in order to make your code migrate to Indigo more smoothly. The reason for this is that Indigo makes no supposition around how your code will actually be hosted. You might be hosted inside an exe, inside IIS, inside some completely different technology entirely, and you might be running over TCP, which means that the HTTP context doesn't really have any context at all. Yeah? Enterprise services, try and avoid passing object references around. If you're passing object references rather than by value data types, then you're going to be into difficulties when you port your code to Indigo because you're going to have to do work to re-engineer those interfaces. Try not to use the native COM+ MSMQ APIs. We strongly urge you to move your code, to start thinking at least about moving your code to .NET. I know you've heard this for year on year, and I know that you're saying, I've got 10 million lines of code. There's no way in hell I could possibly migrate all that stuff to Indigo. Actually, if it's in C++, you should see what they've done with Doom. Have you seen the Doom 2 port to .NET? It's quite surprising how relatively easy it was. So think about moving your code. I know it's going to take time. This is going to take quite considerable time in certain scenarios. But moving to the .NET framework gives you an enormous benefit in terms of security, manageability, reliability, and availability in particular. You could potentially get some performance improvements as well. I was speaking to the guy who's lead dev for DirectX, managed DirectX, and he was saying that they're managing to get something like 85 to 115% of the performance of raw C++ with the managed version. I said, 115? You're getting faster than C++? He said, yeah, because small objects that you allocate frequently live in level 2 cache, because they're in generation 0 in the garbage collectors. They're guaranteed to be in the cache, which you can't necessarily do with C++. So there are some benefits that can swoop in on you. But take a look at WidBay. Take a look at what the C++ team have done for WidBay. They've done a heck of a lot of work in order to try and make your code work in .NET simply by passing flipping the wax CLR command line switch or compiler switch. Okay, so if you're in C++, you've got a number of options. If you're in VB6, you've got code to port, unfortunately. There are books, tools, people, and techniques that can help you do that, but it really, really is worth doing it. Take your most troublesome component in particular, the thing that crashes twice daily, the thing that's a real pain to deploy or to secure, and port the hard ones first. We find that when people do this, they learn far more in that process than simply porting a simple thing. They go, port the simple thing, yeah, great, it works. That's as I expected. Porting the hard things is where you really learn stuff. And that then makes porting the simple things much, much easier later down the line. Okay? But get onto .NET. It really does make a tremendous difference. So on that subject, at PDC, we had a number of people saying, I tried porting my COM+ components to enterprise services, and they perform so badly, I can't deploy this in my environment. And we were rather surprised by this. So we did some work, and we met with them, and we talked with them, and we did some investigations internally, and we wrote up some papers, which we'll talk about shortly. But the same kind of ideas and the same patterns that we saw, and the same kind of mindset that we saw in those customers who seem to be having problems with enterprise services porting also apply to ASMX when they said, you're telling me to write all my code in ASMX? Oh my God, but what about all my COM+ components? Well, you can interop there nicely. That's fine. You can interop with COM+. That's no problem. But my component here has like halved in speed when I ported it to ASMX. And then we started looking at what they were doing. And what it basically came down to is a question of how much work are the methods of your services doing? If your method does something like add 2 numbers or concatenate 2 strings, then yeah, you're probably going to see a fairly big slowdown in performance when moving to an ASMX fronted service or entirely ASMX code. However, if your method is doing a significant amount of work, the overall cost of any given call is predominantly therefore work, so the cost of the transport overhead is a very small percentage. So you will probably see a relatively small slowdown. Now this is prescriptive guidance we've been giving for years. When you're building your COM+ objects, try and make the methods as heavy as possible. Avoid chatty interfaces. I built one system, so I went to see one customer who had a contractor who was no longer with them, who developed a system in COM+ where he had 23 objects, each of which had around 40 properties and 2 methods, load and save. And they used this inside their banking application, their mortgage application. And what happened was the web service, the ASP website would load up a page, instantiate 10 of these objects, call load on each of them, passing in the customer reference number, waiting for the data to be populated into these objects, drag all the data, field by field, into fields on the ASP page, and present the page. Now note that these components were remote from the web server, yeah, and they wondered why they needed a 16-way box to do it. So every single time they were reading or getting any of these properties, they were going back and forth to the server at the other side. And to save stuff, they did exactly the same. So the form page submit happened. They took the data that was submitted from the form, created the 10 objects, put the data values back in, and went save, 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 save. And they wondered why they were able to support something like 3 concurrent users. Yeah? These are common themes. These are common patterns. This is exactly the same kind of discussion. If all your methods and properties are very chatty and very lightweight and they don't actually do very much and the majority of your time is spent in transport, then when you move to a more expensive transport, are you going to suffer a perf problem? Potentially, yeah. Okay? Try and do more work than you can, in your methods if possible. In fact, one of the benefits that we've seen of moving to our prescriptive guidance around service orientation is that some customers who've done this have taken the opportunity to refactor their interfaces to their systems. Instead of having these 43 objects for any given business operation, they might have to instantiate 10 of them and call several methods. What they do instead is they expose one service, which might say, transfer money and pass in 10 parameters maybe with the customer details and where the money's coming from, where is it going to, and what's the amount and so on. They build this as an ASMX service, and then the ASMX service on the same box has access to the COM+ components, does all the work locally to that box. It's a little bit chatty, but they can still get good performance out of it. Submit all the transactions, and then come back to the caller. And they noticed something like a 70% performance improvement in their application by doing so. Because they were going from the client application, create one of these objects, now call this method, and doing all of this stuff across a very costly wire transport. Okay? So these are rules and guidelines that apply to all systems, whether it's enterprise services, whether it's RPC, whether it's DCOM, whether it's Corba, whether it's ASMX Web Services. It's just about understanding what you're doing on the wire. And back to our enterprise services story. This is the question we were asked at PDC. Okay? I port my COM+ component to enterprise services, and suddenly the performance drops to a small portion of what it was. If you follow our guidance and use just-in-time activation and pooling accordingly, you can pretty much match the performance of C++ from your COM+ code, sorry, from your C# or VB.NET code, if you make methods chunky and rather than chatty as well. So take those three things, just-in-time activation, pooling, and chunky methods, and the chances are your perf is going to match that of C++ ATL. And to prove it, yeah, there's a pattern emerging here. And to prove it, we wrote a white paper, we built the test suite, I actually wrote the code, we started with C++ ATL. I had to remember how to do ATL after about 3 years. It was not pretty. So C++ ATL, I had our devs validate that it was the right thing to do, cool. And then ported that to C#, ripping out all the ATL stuff and just resulting in code, which is great. And then ported that to VB.NET, which was good because I didn't know what VB.NET looked like. And then I ported that to VB6, and I had to have someone help me with that because I didn't do VB before. And we then built a test client application which stressed these things out. And we had two methods, one of which was add two numbers together, and the other one was connect to a database, write a SQL statement to the database to insert a record, not read, because reading is very fast on SQL. We wanted something a bit heavier. Insert a record, and then come back. And we tested it with and without just-in-time activation and pooling. The paper is at the bottom of the page there, and is also on MSDN if you want to go read it. .NET Enterprise Services Performance, where we have the result charts, how to configure it. So we have the result charts, which are enlightening in themselves. And here's where we add .NET to the picture. And here is our result. So the purple bar is C++, then VB6, C#, and VB.NET. And this is using just-in-time activation and pooling with chunky methods, hitting the database. We got pretty much identical results across all of the languages by using our prescriptive guidance, by using the best practice guidance. Okay? So the leftmost chart is in proc, the middle chart is out of proc, and the right-hand chart is cross proc. And the amazing thing here is that regardless of where the components were run, they were throttled by the speed of the database. Okay? So you may or may not see a performance improvement by moving in proc or out of proc, depending on your scenario. Just be aware. But our recommended guidance, in particular for ASMX, is run your COM+ components on the same box and in proc, especially if they've been implemented using enterprise services. That's .NET code, sitting on top of a very reliable native engine, fair enough, but it's then running in proc with a brand new, a very powerful execution engine. It's a very, very powerful business engine. Okay? So what about ASMX and remoting? Now, we have Ingo actually working on a paper literally as we speak. He's not here this week because he's writing the paper. He's going to be at TechEd in Europe if anyone's managed to get an expense budget for that. And he did a paper a couple of years ago, actually, which compared ASMX and remoting performance, which is very worthwhile having a look at. He changed company name about a week ago, and I haven't updated my slides since. So it will bounce you to another company. But go and take a look at his list of articles, and there's a paper in there on remoting versus ASMX perf. What he's doing for the next paper for us is extending essentially his original paper and my COM+ paper, and actually maybe to write in English. And he's putting together an entire suite that allows you to compare and to contrast all three technologies in different scenarios. So keep your eyes open for that one on MSDN in the next few months. Okay? But the general story here with ASMX and remoting is that, no surprise, remoting binary serialization is the quickest of the lot. Okay? That shouldn't be a surprise. But it's not as fast as DCOM. And then, when you say, okay, so what if I'm going to do SOAP serialization then? And the surprising thing there was that ASMX is actually faster than remoting. Okay? So take a look at his paper, and keep your eyes open for the next one. I'll leave it at that for now. To be continued. So the perf guidance. The guidelines and the rules tend to be immutable across technologies. Minimize network traversals. We've known this for years. Try not to touch the wire or the ether if you really don't have to. Okay? Chunky interfaces equals better perf than chatty, as a general rule. Component technologies often obscure boundaries. When I say new object, where is it? I haven't got the faintest idea. I may assume that it's on the local box, and because it's on the local box, this interface is a bit chatty and therefore won't worry me. But of course, in the live environment where the component's often on a different box and there's proxies and networks involved, that could be a very bad story. Okay? And service-oriented systems is definitely the way to go. When you think about service-oriented systems, when I say, for example, especially in Indigo, when you want to make a reference to a service that exists elsewhere, you don't say new service. You actually have to make a very explicit call to create a channel to a typed service if you want typed channels, but yada yada, we'll go through that next year maybe. So you have to make a very explicit call to create a reference to a channel to another service. That's making a very strict upfront decision from the developer's perspective that he understands or she understands that this isn't necessarily a local service. It may be local. It might be on the same box. And on the same box, Indigo will say, aha, that service here, same IP address. Great. I'll go down to an IPC call then. So I won't be doing HTTP unless I particularly want to configure it to do so, which I can still do if I want. Okay? So in the Indigo world, I will have on the same box IPC between two things, more often than not. And that in itself will be a big benefit from having to hit the network stack all the way down and all the way back up again on the same box. Okay? Cross boxes, probably TCP if they're both Indigo. If I'm talking to an IBM box over here, it'll probably be SOAP over HTTP. Okay? Until we get binary serialization, sorry, binary XML, whatever version or standard or flavor that's going to be, we're going to have to go with that. But that's the kind of way we're going. This is the kind of mindset that we've got inside the team right now. Love it or leave it. I'm not saying that you have to do the same thing. But we would like you to start thinking in that kind of way as well. Start thinking about composing your systems into services. Start thinking about service orientation as the design mindset that you're going to have when considering sticking your systems together or even implementing brand new systems as well. Okay? You can build this stuff today. You can do it. We do it daily. Clemens, is he here? He's here. Clemens is in the back here. And Clemens and I have been working on the design of an application which we're hoping to have in time for you for TechEd this year, but alas, the gremlins got in there. We're hoping to find a channel through which we can actually announce this application. But it will give you a pretty good idea as to guidance in terms of how to implement service-oriented applications using our existing technologies. And if you want to come and talk to us about it, we're out at the stand later on. Okay? So you can do it. You can build this stuff. If you want some more information until we publish the SO paper, come and take a look at my blog. I haven't written anything up there for weeks. I do apologize. But come and take a look up here. This is where I'm going to be putting stuff on, prescriptive guidance and perf and all manner of other things as well. So take a look up there. There's also already a lot of stuff discussing service orientation and remoting and is it dead and all those kinds of things. Okay? So hopefully that's given you a taste of what we're about. the taste of where things are likely to be leading, and hopefully given you some good guidance on how to use our technologies and where to use them most appropriately to ease your path to Indigo later, to ease your migration and your wire-level integration with Indigo later, and also make it an awful lot easier for you to build systems that can be interoperated with from other services and platforms as well. Okay? Enjoy the rest of TechEd. Please fill out your session evaluation. If you want to speak now, I'm down here, or alternatively over at the stand later on. Thank you.